This video is going to show you my methods for installing PL259 connectors onto RG8 type cable. The same techniques can be used for RG213 and LMR400. Let's start by looking at some of the tools I will be using to install the connectors. A large flat point soldering iron, rosin core 6040 leaded solder, isopropyl alcohol, flux, slip joint pliers, large cutters, close cutting cutters, a butane torch, silicone lubricant, and either a razor blade or a Coax prep tool. The first way I will demonstrate preparing the Coax is using the prep tool. It is a faster, safer, and more accurate way to prepare the Coax. Place the Coax in the prep tool with the longer blade away from the end that is cut. Once seated, rock the tool back and forth, cutting through the outer jacket, braid, and center dielectric. It may take several twists to get completely through to the center conductor. The nice thing about using this prep tool is that it's set up to not damage the center conductor. You'll feel the resistance become lower as you twist the tool around the Coax. Once it is minimized, you can pull the outer jacket. You'll notice the braid stayed attached to the outer jacket. And then you can twist the inner dielectric back and forth until it ultimately slips off the end. Now that we've removed the center dielectric, we've exposed the center conductor. I like to take the opportunity to go ahead and apply a little flux, followed by a quick tinning of that center conductor to keep it from untwisting during the rest of the connector assembly. It doesn't take a lot here, just a light tinning of the center conductor. Now we'll measure back roughly ½ inch and use the other side of the Coax prep tool. This will cut through the outer jacket, exposing the braided shield beneath. Again, rocking the tool back and forth, we'll set the blade and trim back down to the braided shield. This particular prep tool features a knife to be able to cut the outer jacket loose, allowing for easier removal. You can also use a pair of small cutters to peel back the outer jacket. Next, we'll want to apply a little flux to the outer shield, and we're going to tin that as well. That'll keep this from unraveling and fraying during the next portion of the connector assembly. The key while doing this is to not apply too much heat as to melt the center dielectric. Be sure to try and coat all sides of the braided shield. I also like to take the close cutting cutters and trim back some of the braided shield away from the dielectric. Now we will install the barrel over the Coax. It is super important that this is done, as once you solder the rest of the connector on, you will not be able to install this barrel. I now take a small file and run it through the small openings of the connector to remove the plating. This will greatly help the solder process. Next, apply a little bit of silicone lubricant to the outer jacket of the Coax. This will help the connector slip and thread onto that jacket, as well as provide additional weatherproofing. We're now ready to thread on the connector. It's okay to use the pliers here to help thread the connector on. Once the connector is fully threaded on, you should see the tinned braided shield from earlier, as well as the tinned center conductor. Now it's time to solder. It may be handy to clamp the coax in a vise. We'll start by soldering the center conductor to the connector. Next, use a rag and some isopropyl alcohol to clean the flux from the center pin. You can see we have a nice solder joint between the center conductor and the connector. Now we will apply some flux to the braided shield and preheat the connector a bit with a butane torch. Again, we'll feed the solder in through the small hole and we'll repeat for all 4 holes. It's a good idea to keep the rag handy to cool the connector once it's been soldered to keep from melting the dielectric. We'll also take this opportunity to clean any flux left over from soldering off of the connector. Your solder joints should be smooth and clean. Now it's time to test our connector. First, connect both meter leads of a digital multimeter together. This will help us verify and validate our leads are good and meter is in working condition. Next, we will take one lead and connect it to the center pin, followed by one lead to the outer shield. Your meter should display a 1 or OL for open loop. This indicates there are no shorts in your connector. Finally, thread the barrel over the connector to complete the installation.